Chapter 2. To be or not to be prime. Okay, now let's take another look at the example chart I showed you in the last chapter. Do you remember when you looked at the seemingly useless pattern of hexadecimal digits in each column? Well, get ready, because here comes the fun part. Each hex digit, as you should know by now, corresponds to a group of 4 binary digits, and the value of each binary digit reflects whether or not the base 10 number represented by its place in the pattern, as explained in Chapter 1, is prime or not. Alright, I admit that sounds like a mouthful. Let's go back to some numbers that we worked with in the last chapter. Take column 5 again. This should be an overly simplified example, but look at the example hex filtration chart and write out each hex digit you see in the 5th column, and also place next to each hex digit the 4 binary digits for which each hex value corresponds. If you've done everything correctly, then you should have written a hex F with binary digits 1111, a hex D with binary digits 1101, and another hex D with binary digits numbers 1101. Okay, now, remember from the previous chapter that we determined the binary digits in column 5 also represent the base 10 numbers 41, 43, 45, and 47, specifically in that order. With this information, you should realize that the first binary digit from each of the hex digits found in column 5 all represent the number 41, and the secondary digit from each group of hex digits represents the number 43, and so on with 45 and 47 respectively. Now compare all of the first binary digits from each set. You'll notice the digits are all ones. This means that the base 10 number, i.e. 41, which they represent, is a prime number. Next, compare the second binary digit in each set. As it turns out, they are all ones also, so the number 43 is, as such, also prime. However, when you compare the third binary number in each grouped set of associated binary digits, you will see that 2 of these values, the ones associated with the hex digits which happen to have the value D in this column, have a binary digit value of 0. This 0 value means the third number represented by these digits, i.e. 45, is not prime. It is important to know, though, that even if a single binary digit in that third position of the group set had been a 0, then the correlating base 10 number would still have not been prime. That means that a base 10 number is only going to be determined as a prime value when all of the binary digits in that base 10 number group position for the binary set, represented in each of the column's hex digits, all have a value of 1. I'll leave the 4th binary / base 10 number associated with each group binary number set up to you to determine. However, by now it should not be any challenge to you. At this point, I'd like to point out a little trick I figured to uncomplicate all of this. I noticed that there is only a max number of different hex digits that you will ever potentially find in any column. It happens to be only 6 unique digits. They are 6, 7, B, D, E, and F. All you need to realize is that when converted into their binary counterparts, only the hex digit value 6 will have 2 associated binary zeros in it, the first and 4th binary digits. Knowing ahead of time where the binary zeros are positioned within the group makes it easy to know which of the associated base 10 digits are primes and which are not. I think this could use an example or two. Let's look at a new column. I think column number 34 would be fun. What hex digits do you see in that column? Quick! The first hex digit you will see is a 6, which means that the first and 4th numbers represented by the associated binary digits are not prime. Next is a hex digit B. I hope it should be obvious by now that this means the second binary / base 10 digit, according to the associated binary group, is also not prime. The following hex digits simply validate what has already been determined, which is the first, second, and fourth digits are not prime. As such, by process of elimination, we have found that the third digit is prime. And since we can easily determine what number that digit represents by calculating 34.5 times 8 plus 1, we know the base 10 digit value, number 277, is prime. Do we need another example? Well, just for good measure and for fun, I'll provide one more. Let's take column number 41, not to be confused with the base 10 number 41 we calculated earlier. I think we can do it quicker than before. First thing I suggest is that you look for a hex B and a hex D, because I think it's easier since their associated binary groups aren't affected by the hex 6 binary group pattern, which can seem to kind of complicate things slightly. You can see that column 41 has a D but no B, so we now know the second digit is prime. But the third one is not. Next, I suggest we look for a 6, a 7, or E, because these hex digits will tell us that the first and fourth digits in their associated binary group set are not prime. As it so happens, this column of hex digits does not have a 6, but it does have both the 7 and the E, which of course validates that the first and fourth base 10 numbers represented by their specific position in the binary groups are not prime. Now, for no real reason, I think we should check out what that prime number that we found, i.e. 41.25 times 8 plus 1, equals. Well, 331. Easy, right? Who would have thought prime numbers could be so easy to find? Example flowchart for column number 41. Okay, first look at chart 1A and find column number 41. Look down the column to find hex digit B or D. Digit list F, D, E, 7, D, F, 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 F. If both B and D exist, then base 10 digits 2 and 3 are not prime. If there is not a B digit, then the second base 10 digit is prime. If there is not a D digit, then the third base 10 digit is prime. Second, look down the column to find hex digits 6 or 7 or E. Digit list F, D, E, 7, D, F, 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 F. If all three digits, 6 and 7 and E, exist, then the base 10 digits in position 1 and 4 aren't prime. If either 6 or both 7 and E exist, then base 10 digit positions 1 and 4 aren't prime. If there is only a 7 digit, then the base 10 digit position 4 is prime. If there is only an E digit, then the base 10 digit position 1 is prime. Ignore all F digits as they assume all digit positions are prime. F digits are simply pattern placeholders for the pattern expressed in each row.